If I look at something like this, I'm going to factor it completely. And when we look at this first one, there's a giveaway here. The fact that there are 4 terms is always a giveaway for factoring by grouping. So I group them. Out of the first 2, I can factor out an x squared, which leaves me with a 2x plus 1. Out of the second 2, I can factor out a negative 4, which leaves me with a 2x plus 1. So now my 2 factors are the 2x plus 1 and the x squared minus 4. But I'm not finished yet. I want to factor this thing completely. And this thing right here, the x squared minus 4, is a difference of squares, which means it factors into an x plus 2 and an x minus 2. Okay? If I look at the next one, this thing is quadratic in form. In other words, I have something squared, something to the first, and then a constant term. It just so happens that the thing I'm squaring is x to the fourth. So really, when I think about this thing, I want to think of it this way. I want to think of factoring it the same way I would this trinomial, x squared minus 3x minus 18. If I were to factor this thing, I'd build a bridge. 2 numbers that multiply to a negative 18 but add to a negative 3 are a negative 6 and a positive 3, so it would factor into an x minus 6 and an x plus 3. Since this thing is quadratic in form, I do the same thing. I build a bridge, I get a negative 18, it's a negative 6 and a positive 3. And here, instead of an x minus 6 and an x plus 3, I need an x to the 8th, which means each of these have to be x to the 4th. Okay, so it's an x to the 4th minus 6 and an x to the 4th plus 3. Okay, it's quadratic in form. It follows the same pattern. I can factor it just like I would a quadratic, but I have to change that first term. Okay. In number 9 here, I just want to factor out the greatest common factor first. So I'm going to take out a 2x cubed out of this, a 2x squared out of this thing. When I factor out a 2x squared, it leaves me with an x cubed plus 27. And I'm not quite finished here because x cubed plus 27 is a sum of cubes. So this guy's going to tag along for the ride. The sum of cubes factors into a binomial and a trinomial. And now I fill in the signs. This one is the same. This is the opposite. This was always a plus. Remember, this is one of our SOAP problems. Same opposite, always a plus. The cube root of x to the 3rd is x. The cube root of 27 is a 3. And now I just take this term and square it, which gives me an x squared. For my last term, I take this term and square it, which gives me a 9. And then the middle term, I just multiply the 2 from the binomial. I multiply the x and the 3, which gives me a 3x. So that's my middle term. Okay, and really it's just about memorizing that pattern. And the other way to consider this is, you know that this term here times this term has to equal the x cubed. You know that these 2 multiplied has to equal the 27. And then the middle term is just the one you have to remember, that when you multiply those together from the 2 binomials, that gives you the middle term. And that's it. Okay? If I take a look at the next one, I want to solve this one by factoring. If I want to solve by factoring, I have to factor it first. So this one's got 4 terms. I'm going to factor by grouping. Out of the first group, I can factor out an x cubed, which leaves me with an x minus 1. Out of the second group, I can factor out an 8, which leaves me with an x minus 1. So now I have an x minus 1 as one of my factors. My other factor is the x cubed plus 8. And now the x cubed plus 8, that is a sum of cubes again, which means it's going to factor into a binomial and a trinomial. And now I have the binomial. I take the cube root of each of these, gives me an, let's fill in the signs first. This sign is the same. This sign is the opposite. This one's always a plus. The cube root of the x to the 3rd is x. The cube root of 8 is a 2. And now I square that first term as x squared. I square the second term, that's a 4. And now I multiply 2 times the x as a 2x. Again, it's all about memorizing that pattern. And now I just set each factor equal to 0. X minus 1 equals 0. X plus 2 equals 0. And then I also have to do the x squared minus 2x plus 4 equals 0, which that one's just going to be a little bit tricky. Here I add the 1 to each side. Here I subtract the 2. These two are easy. I get x equals 1, and I get x equals a negative 2. But now this trinomial, I'm going to take this off to the side up here. This one can't be factored, which means I need to either solve by the quadratic formula or completing the square. Since I have an a value that's 1 and a b value that's even, I'm going to complete the square, so I subtract the 4 from each side. So I've got x squared minus 2x with a little space equals negative 4. I take the b value divided by 2 and square it. That gives me a plus 1. Whatever I do to one side, I have to do to the other side. So now this factors into an x minus 1 squared equals a negative 3. I take the square root of each side. So that gives me an x minus 1 equals plus or minus I root 3. Remember, the square root of a negative is an I. And now I add the 1 to each side and find out that x equals 1 plus or minus I root 3. So when I solve this one, it gives me x equals the 1 plus or minus I root 3. Okay? And those are my 4 solutions. And it makes sense that I would have 4 solutions because this is an x to the 4th, and that's my fundamental theorem of algebra. Okay? If I take a look at the next one, this one is quadratic in form. So I build a bridge, 2 numbers that multiply to a 4 but add to a negative 5, or a negative 4 and a negative 1. So that means this is going to factor into a value minus 4 and a value minus 1. And since this is an x to the 4th out front, it means each of these has to be an x squared. When I multiply them, it has to give me the x to the 4th. But again, it factors the same way that a regular quadratic would. It's quadratic in form. And now if I look at each of these things, the x squared minus 4, that is a difference of squares, so it factors into an x plus 2 and an x minus 2. This one factors into an x plus 1 and an x minus 1. And now I set each factor equal to 0. When I set this first one equal to 0, I get a negative 2. Here I get a positive 2. Here I get a negative 1. And here I get a positive 1. And you can leave your answer like this if you'd like. If you want to condense it and write it as x equals plus or minus 1 and a plus or minus 2, that's fine as well. Okay? If I look at these next couple, I want to use long division or synthetic division. Remember, synthetic division can only be used if I'm dividing by a binomial of the first degree with a leading coefficient of 1. So this first one, I've got a w squared that I'm dividing by, so I can't use synthetic division for this one. So I'm going to put the w squared. And notice I'm missing a term in this denominator. I'm missing the w to the first. So I'm going to put a 0 in its place, and that typically makes things much easier. So I'm going to do w squared plus 0w plus 3. And I'm going to divide that into this thing. So now I just compare the first terms. W squared times what will give me the 3w cubed, and that's a 3w. So I multiply the 3w by what's out front, which means I'm going to have to use my distributive property. And when I do that, it gives me the 3 terms of 3w cubed plus 0w squared plus 9w. I'm going to subtract this whole thing, which again, subtracting is same as adding the opposite. So when I do that, it gives me a 7w squared minus 13w, and then I bring down the next term, which is the plus 3. And now I start the process over again. W squared times what will give me the 7w squared? It's going to be a plus 7. So now I multiply, that's a 7w squared plus 0w plus 21. And now I'm going to subtract, which once again is the same as adding the opposite. And when I do that, it gives me a negative 13w minus 18. And I can't turn a w squared into a negative 13w, so that's my remainder. So I put a little plus sign here. I write the negative 13w minus 18 over the thing I was dividing by, which was the w squared plus 3. And that's it. If I look at the next one, in this one, I've got a y squared plus 2y minus 1. And I'm dividing that into this 6y to the 4th minus 6. And I'm missing a bunch of terms here. I've got a 6y to the 4th, but I'm missing the y to the 3rd. I'm missing the y to the 2nd. And I'm missing a y to the 1st. So I want to plug zeros in for each of the missing terms to make this a little bit easier. And now we did the same thing I did in the previous problem. Y squared times what gives me the 6y to the 4th, and that's going to be a 6y squared. And now I multiply by what's out front. That's a 6y to the 4th plus 12y cubed minus 6y squared. And now I subtract, which is the same as adding the opposite. When I do that, it gives me a negative 12y cubed and a plus 6y squared. I bring down the next term, which is the 0y. And now I start the process over again. Y squared times what gives me a negative 12y cubed. It's going to be a negative 12y. And now I multiply. That's a negative 12y cubed minus 24y squared plus 12y. And now I'm going to subtract, which is the same as adding the opposite. When I do that, it gives me a 30y squared minus 12y. I bring down the last term, which is the negative 6. And I start over. I'm going to have to multiply by a 30 here, which gives me a 30y squared plus 60y minus 30. And now I'm going to subtract, which is the same as adding the opposite. And that gives me a negative 72y plus 24. And I can't go any further, which means that's my remainder. So I put a little plus sign here. It's a negative 72y plus 24 all over the thing I was dividing by, which is the y squared plus 2y minus 1. Okay? And that's it. So again, these problems are not super difficult, but there are a lot of tedious little things that we have to be aware of, and a lot of places to make sign errors, so just be very, very careful. Okay? In number 14, this one can be done with synthetic division because I have a binomial of the first degree with a leading coefficient of 1. Okay? So when I'm doing synthetic division, I basically take the root of this thing, which is what I would get if I set this equal to 0. If I did x plus 3 equals 0, I would find out that x equals a negative 3. That's what I want to plug into my box as a negative 3. Okay? It's the 0 that I would be using here. And now I write down my coefficients, a 2. I'm missing an x squared, so I got to put a 0 in its place. And now I bring down that first coefficient. I multiply. I add straight down. I multiply. That gives me an 18. I add straight down. I multiply. That's a negative 66. And I add straight down. That's a negative 72. So now if I started with an x cubed up here, my answer is going to start with an x squared. So that's a 2x squared minus 6x plus 22 plus a negative 72 over the thing I was dividing by, which was the x plus 3. Okay? In the next one, this one I can't use synthetic division for the way it's written, but remember I have a little trick that I can use here. Since this is essentially a fraction, I can divide the numerator and denominator by the same thing, and it doesn't change the fraction, just changes the way it looks. So in other words, I can divide this by 3 and this by 3 and come up with a new equation. My new equation would be this. If I divided that first piece by 3, that's going to give me a 2t cubed plus 5/3 t squared minus 2/3 t plus 1/3 divided by, that's going to be a t plus 1/3. And now with this new equation written this way, I can use synthetic division. So I'm going to put the negative 1/3 in the box. And I'm going to write down my coefficients. And I'm going to start the same process I did earlier. I bring down the 2. I multiply a negative 1/3 times 2 is a negative 2/3. When I add straight down, that gives me 3/3, which is 1. Now I multiply. That's a negative 1/3. When I add straight down, that's a negative 3/3, which is a negative 1. And then negative 1/3 times negative 1 is a positive 1/3. And when I add straight down, that gives me a 2/3. So what this translates into is a 2t squared plus t minus 1 with a remainder of 2/3 over the t plus 1/3, the thing I was dividing by. And there's a little bit of an issue here. I can't leave it this way because I can't have a fraction within a fraction. So I'm going to multiply this remainder by, 3/3, just to get rid of those fractions. And watch what happens here. I've got the 2t squared plus t minus 1. But this fraction, when I do 2/3 times the 3, it gives me the 2 in the numerator. In the denominator, when I distribute that 3, it gives me a 3t plus 1, which is the thing I originally started off with when I was doing my division. Okay?